We will obtain the quantum harmonic oscillator spectrum from phase space considerations. We start with the harmonic oscillator Hamiltonian, which is the momentum square divided by 2 plus the position square divided by 2. And compared to standard treatments, I've set the frequency to 1 as well as the mass. It will be an exercise to restore them. If we draw the phase space, which is the position momentum space, we can just draw a vertical and a horizontal axis. Let's say the vertical axis represents momentum, the horizontal axis represents position, and then constant energy phase space trajectories are circles centered on the origin. This is because the Hamiltonian is basically the radius square divided by 2, and this is equal to the energy. So this is the classical harmonic oscillator in phase space. We can now use the following rule. A phase space cell of size the Planck's constant corresponds to precisely one quantum state. We will denote Planck's constant by h. And so we can now look for the ground state. The ground state is the one with the smallest energy. It will be concentrated, therefore, near the origin. So we draw a little disk. And we wonder what's the radius of the disk such that the area occupied in phase space, which is pi r square, equals Planck's constant. That will represent one quantum state. If we denote by h bar Planck's constant divided by 2 pi, then we find that the radius square is equal to h bar times 2. So this is the outer radius of this disk. Now, what is the energy of the state corresponding to this disk? Well, there are two corrections. First of all, the energy is equal to the radius squared divided by 2. So naively, this would be h bar. However, the average energy is actually somewhere in the middle of the energy range between 0 and h bar. And in particular, we can divide this phase space cell into two parts with equal area. We will find that the radius corresponding to the separation line, the radius square corresponding to the separation line, is equal to half the radius 2h bar. So the average energy of the ground state is equal to h bar over 2. We can now repeat this reasoning for the next phase space cells. And we find that they correspond to radii, which are 2 times n plus 1 times h bar. Because each time the area between two of these circles grows linearly with r square. So this is the outer radius. So the outer radius is 2n plus 1 h bar for the nth cell, while the inner radius is 2 times n h bar, and the average radius square which is twice the energy, will be twice n plus 1 half times h bar. Therefore, the energy of the harmonic oscillator states is n plus a half h bar. This is indeed a standard result, which we have obtained from a very intuitive phase space quantization.